Hello everybody, my name is Damugas and welcome to my Airflow introduction videos. Today we will be using Xcoms to allow tasks to communicate to each other. Let's assume we want to do a task that's backupping some files on our Airflow server. In this example I created in total 4 tasks that read data from a previous task. The first one is the list DAGs task. It will read the current directory where all DAGs are located inside the Airflow installation. The parallel task, create backup directory, will make sure that the backup directory exists. Then we will trigger the backup DAGs bash command, which will copy the appropriate DAGs into a different directory. And because we will have some issues with this DAG, I will provide you with the backup by Python solution, a different approach that's using the Python operator. As you know from the previous example, we will be using the imports you're already familiar with, which is pendulum and datetime, of course. And then we will use some implementations from the Airflow library itself, which is on the one hand the DAG based in the models package, the bash operator, which you already are familiar with, and the new Python operator, which is located in the Python operator module. Additionally, I added here shutil later on for copying the files using the Python operator. Here you can see the backup by Python callable function, which is executed by the Python operator. It will use the arguments provided here and extract from these arguments the task instance, which is referenced as TI. This I save to the task instance variable, and using this variable I can call xcom pull on it to retrieve the data of the provided list DAGs tasks. This information is saved into the pass variable, allowing me to iterate over the resulting elements. I will split the content by space, assign them to the path variable, and build up the appropriate path I want to backup the data to. On the one hand side, I have the source directory, which is user local airflow DAGs and then the appropriate file name. And on the target side, user local airflow backup with the appropriate file name. For additional verbose output, I print here also these informations as well, which you can later on remove if you don't think they are necessary. And then calling actually the shutil command by copy using the source and the target. I will use the already args directory, which you're already familiar with, using the same settings as we used them before, and create a new DAG instance here using a different name, this time using it as Xcoms. Make sure you don't use the same name as previously, otherwise your DAG will not appear in your Airflow installation. Let's now start with the actual bash operator. We will list the content of our DAGs directory and remove everything that's starting with __pi, which is in our case the cache folder of Python, which we don't want to backup because it's not required. By default, ls will move each element into a new line. But for debugging purpose and splitting this operation into several tasks, it's not really required to have them separately. Also, the last output will be provided back to the Airflow installation, which is nothing we want to have. We want to have everything in one line. That's why we use xargs here. Later on, I will show you in the UI how the output works. You also have to remember to set xcom push to true, as by default output of a bash operator will not be propagated back to Airflow and will just be dropped. The next one is the bash operator using the task used for the task create backup directory. We will be using mkdir-p for create the appropriate backup directory, and -p will make sure that this directory, even though it exists, will not destroy the bash command. Now, as we have the output as a separated list of elements into one line, we can just use the pipe operation here So inside, I will just echo the output here that you can actually see the issue with these Xargs, using of Xargs here in this place. And I also provide you with a solution, which I already explained to you, using the splitting, using a small Python function by the Python operator and having the task backup by Python. You have to make sure that I provide the context to the function, otherwise I'm not allowed to access these task instance value from this args directory here. And finally, we glue everything together by using these bigger smaller notation here. These will make an order from left written to right written. These brackets allow both tasks to run independently, so also in parallel. Because they are not dependent to each other, you always have to think about if there is any execution dependency. You should also tell Airflow, otherwise Airflow will run them in any order, so when you have dependencies there is a high chance that they will break. And after the listing and the backup is finished, then Airflow will just start the backup dex execution, and when this is finished, the backup by Python task will be executed. Let's now trigger the DAG and see what actually is happening. First of all, the state of all executions will be resetted. You can see here that both tasks are queued in parallel. And when you now hit the refresh button, and when you now hit refresh in your browser, you will see that this first may have already succeeded and the second one is still queued. You can view the logs of the task actually here. As you can see from the script location here, they are written to a temporary directory. I would always recommend using absolute path when you do something with file related topics in Airflow, to make sure that you always have the source and the target like you want them to have. This ls will show us all the Python files. These will remove the cache, and these will move these 2 lines in our case into 1 line, resulting in this output. Important is as well the exit code. When it's not equal to 0, Airflow will mark this task as failed. You can also take a look at the output which this task created by clicking on Xcom and the top of the page. And again, you can see here the return value of the function. Paths we already know. Now let's take a look at the create backup directory. You will notice here that you have no output. One reason for this is because mkdir in general don't have any output, but even though you would use echo or something different that creates an output, it will not be propagated to Airflow because we don't set Xcom push to true in our DAG definition for this appropriate task. The next one will be backup DAGs. And this is now echoing just the path. Because I found it not that easy to use this format for backupping by single in bash, I just skipped it out and will just show you the output, how you can actually use it. The mont listing output is of course the Python operator. This will run now our small snippet we just created, and because we used a print statement, these log informations are also present here. From user local Airflow DAGs test DAG, the data is copied to the backup test DAG path. And as we don't have any return value, the return value in this case is none. Python operator always have a return value and propagate this back to Airflow. Bash operators by default don't propagate the return value. Thank you for watching. I hope you learned a little bit. Feel free to leave a comment and click subscribe to get even more content from me. Thank you.